amplitude is 6. Okay, so notice that when we created our equation, we could verify from the graph that everything is correct. Okay, let's go back and we're going to do this differently now. I'm going to give you an equation and you're going to sketch a graph. Okay, so I'm going to show you how to do that. It's actually a lot simpler than it seems because of everything that we know. Okay, so we're going to keep this with relatively simple numbers. Okay, so let's say I give you y is equal to 2 sine 1/4 x minus 3. So how do we graph this? Well, let's start by identifying the things that we need to know, okay? We need to know the period, the frequency, although I would say if you know the period, the frequency should, you probably don't need to know the frequency. The period is more important than the frequency when graphing. So you need to know the midline, the period and or the frequency, and the amplitude. So let's first identify that, and then I'll show you how you can do the graph. Okay. So what do we want to do? Let's start with the midline. So to identify the midline, we're looking at this right here, at this minus 3. So y is equal to -3. Now our amplitude, these are the easiest things to identify. The amplitude is our vertical stretch or shrink. So this is a vertical stretch. Our amplitude is 2. Our frequency is also given to us. Our frequency is b equals 4. Which means our period is 2 pi over b, which is 2 pi over 4 or pi over 2. Okay, these are the different things that you need to know. Notice I'm not, when you graph this, we're not doing a translation left or right. Okay, so how does this help us? Well, here's what I would do. I would start off with your midline. Okay, so we're going to do our midline. And then our amplitude and our period kind of come together, okay? So I would do your period next. And then we'll do the amplitude. So you'll see why it's in this order, okay? So we're going to draw the graph. And again, you can come up with your own stuff and then verify it using the Desmos graphing calculator, okay? So before we actually graph it, I want to show you y equals sine x again. Because this is what you're going to use, okay, as your guide. Okay, here's 0 to 2 pi. And I'm actually going to take out this step and make our step pi over 2. Okay, this will help us. So our amplitude, and let's go up by 1. Let's just step by 1 here. Okay. Okay, so what is this? Sorry about that. I just want to show you because this is going to be how you're going to do this, okay? So we have pi over 2. So I want you to notice something about the sine graph. It starts at 0, right? Every wave starts at 0. So we are not changing the translation left or right. So this is always going to be true. So we're not really, don't think of it as starting at 0. Think of it as starting at the midline. So at 0, you're at the midline. And at 2 pi, after a full wave, okay? So again, don't think of it as 2 pi. Think of it as a full wavelength as you come back to 0. Halfway through, you're at 0 again. And then halfway through that, in the first half, you're at 1, so you're at your amplitude, you're at your highest point. And then in the second half, you're at your lowest point. So you're kind of dividing this into 4 different pieces, okay? 4 different sections. From your first section to your last section, from your first point to your last point, to a complete wave, you go from 0 to you go from your midline to your midline. Exactly halfway through, you're at your midline again. In the first half, exactly halfway through, you're at your maximum. And in your second half, exactly halfway through, you're at your minimum. Okay. You can do the same thing with cosine. You're looking at where you are related to your minimum and your maximums, okay, and your midlines. At the very beginning of the wave, you're at your maximum. At the very end of the wave, you're at your maximum. At the very middle of the wave, you're at your minimum. The middle of your first half and the middle of your second half, you're at your midline. So if you forget, okay, draw a very basic sketch of the cosine graph and the sine graph using the unit circle. And then what you're doing is you're saying, okay, well, where am I at the beginning and the end of the wave? Where am I at the exact middle of the wave? And where am I halfway in the first half and halfway in the second half? And that is going to help you. So you're going to see how we do that. Okay? So, we only have to draw in the positives. Okay? And here's what we're going to do. We're going to start at 0, and the next point that we're going to draw is pi over 2. Okay? So this will be the first x value we put in. Okay? And it's at the period length. So our period is pi over 2, so this is going to be pi over 2. And if you notice, we're dividing it into 4 parts, right? So we're going to take pi over 2 and we're going to divide it in half. This is going to be our second point. When we take pi over 2, we're dividing it in half. Pi over 2 divided by 2 is pi over 4. And actually, we could put in our midline first. I didn't put that in first, but we can do that first. So we're going to do 1, 2, 3. This is our midline. Okay, so we could put that in first. So this is exactly halfway. I'm going to take that out. We took pi over 2 and we divided by 2. Okay. Now, where's our next point going to be? Exactly halfway between 0 and pi over 4. So this is going to be a pi over 8. Okay. So essentially, we took pi over 2 and we multiplied by 1/2. You can multiply by 1/2. That's how we got the pi over 4. Then we took pi over 4 and we multiplied that by 1/2. That's how we got the pi over 8. Now, how do we get this number in the middle, right? Because this number is a little bit more difficult. Well, this is 3/4. It's 3/4 of our period. So it's 3 pi over 8. The other way that you could do this is the same thing as pi over 2 times 1/4. Okay, so if you want to be consistent, you take your period, you multiply it by 1/2, that gives you this number in the middle. You multiply it by 1/4, that gives you this. And you multiply it by 3/4, and that gives you 3 pi over 8 here. So that's how you get those numbers, okay? That's always the case. You always take your period, multiply by 1/2, multiply by 3/4, and then you can multiply by 1/4 if you want to be consistent, okay? If you don't, then you would take this number, whatever the period times 1/2 is, and you would multiply by 1/2, okay? Now we put in the amplitude. So we know this is a sine graph. The first point is at the midline. This is at the midline. Then we know we go up halfway through, we're at the maximum. So the maximum here is the midline plus our amplitude. Which is -1. This is our midline plus our amplitude. We're going up the amplitude because we're doing a maximum. Our minimum is going to be our midline minus our amplitude. This is always true for every graph. Sorry, that should be an A. Okay, so this is a sine graph. So where are we at 0? We're at 0 here. We're at 0 exactly halfway through. And then we return to 0 at the end. In the middle of these points, we're at our maximum. Our maximum, that tells us it's at -1. Our minimum is going to be halfway between here. So our minimum is at -5. Which I'm going to estimate is over here, but we'll actually put it in. And now we essentially connect the dots. Okay, so it's going to look like a sine curve. Looks like a sine curve, but notice it moved. So I'm going to reiterate what we did. Okay, we drew in the midline, then we figured out what these points are, because this is how we're creating our sine graph. So we took our period, then we took our period and divided it in half, and then we divided each of those halves in half. So how did we do that? We multiplied by 1/2, then we took this, we multiplied by 1/4, and we took it and we multiplied by 3/4, because at that point we're 3/4 of the way to our period. Then we used what we knew about the sine graph. The first point, the middle point, and the last point were at the midline. In the middle, at the quarter, we're at the maximum. How do we find the maximum? Well, we know that the distance from the midline to the maximum is equal to the amplitude. So we just took the midline and we added the amplitude. Then the distance from the midline to the minimum, we subtract the amplitude. So that's how we found the maximum and the minimum. And then we just connected our points. And if we want to do this again, we would go again. And we would be going up. This tells us how much you're going up by. You're going up by pi over 8. So you can do pi over 2 plus pi over 8 to get the next point. Okay, let's do this again. And by the way, we can check this. Let's check it, just to make sure it looks okay. We would type in 2 sine of 1/4 x minus 3. I should have closed this parenthesis here. Okay, and this will tell you, did you do it correctly? So you can do a, no, something went wrong. Shouldn't be 1/4, it should be 4. Oh, I did it wrong. Did I do it wrong? I did it wrong when I did it. I'll fix it on the paper. I did it wrong because I said 1/4 x, but it's actually 4x. Okay, so I'm going to change that on the notes here. I did it so that it's 4x. I apologize for that. Okay, I'll put it in red. That was my fault. This is where it helps to be talking to a class, because then they would stop and they would say, Professor Taffy, shouldn't that be a 4? Okay, so 4, frequency b is equal to 4. Okay, and if we look at the graph of that graph, it looks the same as what we did, right? At pi over 2, we've done 1 complete wave. And if you want to do another complete wave, okay, if you want to do 2 period lengths, then you would just repeat the process. Let's do another one. This time I won't mess it up. Let's say that we have y equals 3 cosine 1/2 x plus 1. Okay, so we're going to do all of our identification just like we did before. This time we'll do it correctly from the beginning. So first thing is our midline is y equals 1. Second thing is we said we could do the period and the frequency next. So our frequency, I will correctly identify it this time. Our frequency is b is equal to 1/2, which means our period. So remember, we multiply by the frequency by 1/2. So that means that we double the period. So it goes from 2 pi to 4 pi. If you recognize that, then feel free. If you don't, you're doing 2 pi over 1/2, which is 2 pi times 2, or 4 pi. Okay, and then finally we have our amplitude. So the reason why I say you can do it in this order, the midline and the period, it really doesn't matter. But if you notice, when we plot our points, we plot it after we find where our minimum and our maximum is going to be, right? We're figuring out that our maximum is at pi over 8. So that's why the amplitude is the last thing that you really think about. But in terms of identifying these things, the order doesn't matter. So once again, we're doing cosine. Okay, so we're going to draw our graph. And our midline is at y equals 1, so I'll move this down a little bit. I won't make it exactly centered. Okay, and once again, we're going to take our, so we could start by drawing our midline. Our midline is going to be, so the midline is, our midline is at 1. So the midline, I said our amplitude is 2. Our amplitude is 3. I apologize. Okay, our amplitude is 3. So our midline is at y equals 1. Okay, so I put a dashed line. You don't need the dashed line. I just put it there as a guide for myself. Okay, the dashed line doesn't, you see that when we graph it, it doesn't really exist. It's like the asymptotes. You'll see me put a dashed line when I draw it, but it doesn't really exist. It's just there for, purposes of guiding me as to how to draw the graph. Okay, so the first point that we're going to draw is the end of the period, right? So the first point that we're going to draw is way out here. This is at 4 pi. And then we're going to divide this into 4 sections. So we're going to take 4 pi times 1/2. We could do 4 pi times 1/4. And 4 pi times 3/4. This gives us our 3 points. So 4 pi times 1/2 gives us 2 pi. This gives us pi, and this gives us 3 pi. So here is 2 pi. And sometimes this is going to be really easy to figure out, right? We know that half of 2 pi is pi. We know that halfway between 2 pi and 4 pi is 3 pi. So sometimes it's going to be really easy to figure out. Sometimes it's going to be a little harder. Okay. Then you might want to identify where your maximum is going to be and where your minimum is going to be. So your maximum is the midline plus the amplitude, right? So our midline is at 1. Our amplitude is at 3. So our maximum is going to be at 4. Here's 4. Then we're going to look at our minimums. Our minimum is at the midline minus the amplitude. So our midline is 1. Our amplitude is 3. So our minimum is going to be a -2. And I didn't draw this very well because it's not evenly spaced, all that evenly spaced, okay? But this gives you an idea. Now this is the cosine graph. So if you look at the cosine graph, it looks different. The cosine graph starts at 1 and it ends at 1. Halfway through, it's at the minimum. And then in the quarter sections, okay, half of the first half and half of the second half, we're at 0. So that's what you're going to do. So this is where it matters whether we're doing the cosine or the sine, okay? So if we go back, cosine starts at the maximum and it ends at the maximum. Halfway through, we're at the minimum. And then at these halves, we're at the midline. And remember, you don't draw it like a V. You have to make sure that the ends look like okay. So this is what the cosine graph would look like. Okay, let's do another one. Let's do y equals 1/2 cosine of 2/3 x, 2/3 x minus 2. So we have a lot of fractions here. Don't be scared by the fractions, okay? Fractions they don't make any difference in how you go about doing this. So our midline is at y equals -2. That comes from here, right? -2. Now our frequency is at 2/3. So our period, now remember, it's inversely proportional. So if we're multiplying by 2/3 here, the period we would multiply by 3/2. We would have 3 pi over 2, okay? But if you're not sure how to do it, 2 pi over b, 2 pi over 2/3, we multiply by the reciprocal. So what we get here is 6 pi over 2 which is 2 pi. So that would be the same as taking 2 pi and multiplying by 3/2. Right? These cancel. This gives us 6 pi over 2. If we take 2 pi and we multiply by 3/2, we get 3 pi. Okay, so that's our period. If you notice, what we use to do our graph is the period. We don't use the frequency at all, okay? And finally, the amplitude, which we just take from the front, so that's 1/2. Okay, so how do we do this? First, we draw our axes, and we know that our amplitude is only 1/2, so it's going to be small. We know our midline is at y equals -2. That gives you some idea as to how to draw your axes, okay, in terms of where you want your x-axis. So I know I'm going to stay below the line here. So here's our x, here's our y. You can start by doing the midline at -2. Okay, this is again just to help guide you in your drawings. Okay. Okay, so let's figure out where our x values are. So we're going to do the period times 1/2. We're going to do the period times 1/4. And we're going to do the period times 3/4. So here's 3 pi. Halfway is 3 pi over 2. Half of that is 3 pi over 4. And 3/4 of it is 9 pi over 4. Okay. Now we're going to find our minimums and our maximums. So our maximum is our midline plus our amplitude, or -2 plus 1/2. This is -1.5. And yes, it is perfectly fine. I'm going to just write that so it's clear. It is perfectly fine to do this in decimals, okay? And our minimum is our midline minus our amplitude, or -2 minus 1/2, -2.5. Okay, so we care about this here. This is -1.5, and this here. This is -2.5. Okay, now this is cosine. So cosine starts at the maximum and ends at the maximum. So these are these points. Okay, starts at the maximum, ends at the maximum. Halfway through, we're at the minimum. And then the remaining points, we're at 0. So this is our cosine graph. That was not well drawn. I'm going to redraw it. That was awful. Okay, it doesn't have to be perfect, but it should look pretty accurate. Okay, and if we wanted to, we could keep going. Each time we're going up by 3 pi over 4. Okay, so we could keep going. We're just repeating this. Let's do one last one. Let's do y equals 3 sine of 2x So that's 4. Okay. So once again, our midline, you should be doing this on your own right now. Okay. Midline is at y equals 4. Our frequency is 2. We don't really need the frequency. We need it just to identify the period. So the period is 2 pi over b, or 2 pi over 2, which is just pi. And our amplitude is 3. Okay, so we're going to draw our axes, and we know that this is our midline is at 4, so we have to keep in mind that our maximum, you should have some idea that we need a lot of room above the x-axis just to help you figure out how to draw it. Okay, you should have that in mind. So I'm going to put my x-axis down here. So our midline is at y equals 4. Okay, so that's the first thing that we did. Our points, we're going to have a point at pi. Then we're going to have a point at pi over 2. So here's pi. Here's pi over 2, halfway. Then we're going to multiply by 1/4, which is pi over 4. That's going to be another point. And then we're going to have 3/4, or 3 pi over 4. Okay, so now we need to figure out where our minimum and our maximum is. So our maximum is the midline plus the amplitude. So our midline is at 4, our amplitude is 3, so our maximum is going to be at 7. And our minimum is the midline minus the amplitude. So 4 minus 3 is at 1. So those are the things that we care about, okay? So we need to put in our points. Now this is sine, okay? So at sine, this is a y, by the way. Up here. That did not come out at all. This is a y. Okay. So in sine, we started our midline and we ended our midline. This is why you have to know what the sine and the cosine graph looks like. Now halfway through, we're at our midline. I don't know why it came out all the way over there. It looks perfect on my paper. That's better. Okay, halfway through there, we're at the maximum. And halfway from here to here, we're at the minimum. And then we just connect. And again, it doesn't have to look perfect, okay? This definitely does not look perfect, but you need to try, okay? So now you should have a pretty good idea as to how to do this. Now I'm going to tell you here, this is not on your review sheet. I don't think it's on your review sheet. So if it's not on your review sheet, I will not test it. I will not test you on it for this quiz. It absolutely will be on your final. Okay, so I don't think it's on your review sheet, but it will absolutely be on your final. Okay, so everything in terms of the transformation of waves, the frequency, the amplitude, the midline, the period, All of those things you should be able to identify. You should be able to come up with the equation if you're given those things, and you should be able to graph it. Those things will be on your final, okay? It may not be on your quiz. If it's not on the review sheet, I already posted the review sheet. So if it's not on the review sheet, it's not on the quiz. If it is on the review sheet, it might be on the quiz, okay? But I am 99% sure it's not on there. Okay, so before we stop for today, I want to introduce you. We're going to switch gears completely, okay? We're going to move away from graphs, and we're going to move back to the trig functions. And this is just a quick introduction to what we're doing in the next lecture. And the next lecture takes a lot of concentration, and this is just kind of introducing you to a concept. So I want to do it in this lecture here, okay? So that the next lecture isn't too long and overwhelming. So, and if it makes you feel better, I said that there would be 8 videos in this folder. There will only be 7, okay? Only 7 videos, I think. So that should help a lot. Okay, so the next thing is something called the Pythagorean Identities. So this is your first introduction to identities, okay? These are called the Pythagorean Identities. And it's something that is true about the relationship between the trigonometric functions, okay? It's one type of relationship. There are actually lots of different relationships. This is one type, and it's easy to identify, okay? So that's what we're talking about. And I'm going to give them to you, and we're going to actually derive them. So this is one type of relationship between the trigonometric functions. Okay, so we're going to derive these in 2 different ways. First way, which kind of makes sense, is to use the Pythagorean theorem, okay? So if you remember, Pythagorean theorem for our right triangles is O squared plus A squared is equal to H squared. So there are 3 Pythagorean identities, okay? So we're going to derive each of them using the Pythagorean theorem, and then we're going to derive it in a different way, okay? So let's take the first one. We'll do that one in red. So they're called Pythagorean identities, so they come from the Pythagorean theorem. So let's write the Pythagorean theorem. Okay. And then what do we know? We know that the trigonometric functions are ratios of the right sides of the sides of a right triangle. Okay, so we have O over H, we have A over H, we have O over A. So what we're going to do is we're going to create the ratios here. And the way that we're going to do that is we're going to divide everything by H squared. So if we divide everything by H squared, okay, what we're actually doing is we're creating trigonometric ratios. This is O squared over H squared. That is sine squared. So a little note that I'm going to put off to the side. I'm going to put it in orange. Sine squared theta is saying that you are taking the sine of theta squared. Okay, so sine squared theta is the same thing as O over H squared, or O squared over H squared. This is a shortcut. Remember, mathematicians are super lazy. So This saves us from writing the extra parentheses, okay? You are not squaring just sine. You are squaring the sine of theta. And this will give you an idea as to why we don't use sine inverse of theta with the -1. We call it arc sine of theta, right? We use arc sine of theta. And the reason that we do that is because here we put the exponent between the sine and the theta. So that would be kind of saying that -1 is an exponent, but it's not, okay? We don't raise it to the -1. It's not, we don't use that notation. That -1 is not an exponent. And that can be very confusing. So that's why we use arc sine instead of sine inverse with the -1 up here. Because this is an exponent. This is saying take sine of theta and square the sine, okay? You can't just square sin. That's not possible. So what you get here is sine squared theta. And then what you also get, a over h is cosine squared theta for the same reason, right? A over h is cosine. So a squared over h squared is cosine squared. All we're doing is we're distributing the square. And h squared over h squared, well, that's equal to 1. This is the first Pythagorean identity. They are in no particular order. So how do we get the second one? Well, the second one, pretty straightforward. You start off with the Pythagorean theorem, but this time, instead of dividing everything by h squared, let's divide by o squared. We're still getting ratios, right? So it's totally okay. So what do we get here? Well, o squared over o squared is just 1. A squared over o squared is cotangent squared. And h squared over o squared, well, h over o is cosecant. This is our second one. So notice we're deriving these identities. We're saying that this is true. And the way that we're doing it is we're taking the Pythagorean theorem and we're just dividing by each of the different sides. So not surprisingly, the third one, you start off the same way. O squared plus a squared equals h squared. And not surprisingly, what do? We divide everything by a squared. And it's okay to do this because we're not changing the value, right? This is still Pythagorean theorem. We haven't changed the value because we're dividing everything by the same thing. So this is still an equation, okay? And here we get our third one. O over a is tangent, so we get tangent squared. A squared over a squared is 1. And h over a is secant. So we have our 3. Now here's another way to define it. Okay, we can use the unit circle. So in the unit circle, we said here's theta. Here's x, here's y, and here's 1. This is from the unit circle. Now we also said that the sine of theta is equal to y. And the cosine of theta is equal to x. Now, we know from the Pythagorean theorem right? X squared plus y squared is equal to 1. That's what the Pythagorean theorem is telling us. So, cosine squared theta plus sine squared theta equals 1, or we can write it as sine squared plus cosine squared. And here we have our very first identity. Okay. Note that I'm boxing this one just so that you can see it's the same, but we still have cosine squared plus sine squared theta equals 1 is exactly the same thing. Okay. Then we have our next one. So how do we get the next one? We take sine squared theta plus cosine squared theta equals 1, and this time we divide everything by sine squared. So we're using, not by cosine squared, by sine squared. We're using our different definitions. It's the same definition, but we're saying, okay, sine squared over sine squared over sine squared is equal to 1. Cosine squared over sine squared we know is equal to cotangent squared. And 1 over sine squared is cosecant squared, right? The reciprocal of sine is cosecant. So we're just using those definitions. And then to get the third one, we could do the same thing. We take sine squared theta plus cosine squared theta equals 1. And this time, we divide everything by cosine squared. And again, that's fine. We're not changing the value of anything. We're dividing everything by cosine squared. So we're preserving the equality. Okay, and in this case, sine squared over cosine squared is tangent squared. Cosine squared over cosine squared is 1. And 1 over cosine squared is secant squared. Notice in the Pythagorean identities, every trig function is squared. Okay, that's a part of the relationship. And just keep note that this is not the only way to write sine squared theta plus cosine squared theta. So let's just review that, okay? So our first identity is sine squared plus cosine squared theta is equal to 1. But we can also write this okay. There are two other ways that we could write it, because what we can do is we could subtract cosine squared theta from both sides. We could solve for sine squared. So if you see this is also a Pythagorean identity. And we could solve it for cosine squared theta instead. Okay, so just be aware that these are all three of these are the same identity. We can do the same thing with the others. So with the others, we could take 1 plus cotangent squared theta equals cosecant squared theta. And we can also write this as we could move the cotangent squared to the other side. And make it 1 equals cosecant squared theta minus cotangent squared theta. Or we could solve it for cotangent squared and say cotangent squared is cosecant squared theta minus 1. Always write your thetas, always. I haven't always said it, okay? But you must write it because, again, you have to take the cosecant of something, the cotangent of something. So always write your thetas. And finally, we could take the third one. Third one we found to be tangent squared theta plus 1 equals secant squared theta. And again, we can solve we could either write it in terms of 1. So in this case, 1 is equal to secant squared theta minus tangent squared theta. Or we could solve for tangent squared. Sorry. Which is secant squared theta minus 1. Okay, so this doesn't have to do with our graphs. This is just a relationship between different trig functions. So tangent and secant have a relationship. This is a 2. I'll try and make that clearer. Okay. So tangent and secant have a relationship. Cotangent and cosecant have a relationship. Sine and cosine have a relationship. So these are your Pythagorean identities, and they can all be written in 3 different ways because you can solve it in 3 different ways. So keep in mind that if you see it as any of these 3 different ways, they're still Pythagorean identities. They're called Pythagorean because they're based on the Pythagorean theorem. We derived sine squared plus cosine squared equals 1. We derived it using o squared plus a squared equals h squared. Or we derived it using that x squared plus y squared equals 1 using the right triangle.